Cessna, high wing Cessna, looks like approaching, so let's see if you have your reactor wings. And show me your reactor wings, please.
Under cover of darkness, a small aircraft flies at low altitude along the rugged U.S. and Canadian border, just above the treetops. The drug traffickers are attempting to transport illegal cargo to a remote drop-off location. It's an all too common occurrence over the 4,000-mile remote mountainous wilderness. These criminal organizations take advantage of the rugged terrain using small helicopters, Cessnas, and gyrocopters, because current technology is unable to track these small, dark aircrafts.
The unique challenges we face up here, not only are people being able to walk across the border, basically free roam, it's really tough, we're short on manpower. We also have issues of aircraft coming across. They fly in, at times they land, they drop stuff. It's very challenging as an agent to be able to intercept, interdict, or even get the numbers off of the plane to trace where it is going, where it's been, where it's from.
These aircraft not only support illegal trafficking, they threaten our airspace and national security. U.S. Customs and Border Protection requires a system to detect, track, and classify aircrafts flying below 15,000 feet. In response to this need, the DHS Science and Technology Directorate launched the Small Dark Aircraft Project. The result? A portable, low-cost 24/7 surveillance system that agents use to pre-position assets to intercept nefarious aircraft. When an aircraft flies into a valley, one or more acoustic sensors will detect the sound and identify the aircraft's position. A transmitter floods the valley with radio frequency signals, and the radar receivers detect reflections off the target, creating a comprehensive air picture of the entire area. Agents can select a specific track, review its flight path, and note suspicious activity. Data from acoustic spectrogram and audio files allows them to identify the type of aircraft. Traditional radars do not perform well in rugged landscapes due to dense forest and mountainous terrain. The new surveillance system uses multi-static radars.
We wanted a radar that was simple, was robust to the environment that we would find ourselves in, yet would still meet the performance requirements that we thought this kind of application would have. One of the advantages of this kind of disaggregated design, where we have separate components, receivers, and transmitter, is it allows us to essentially build a coverage area that's very non-traditional and that sort of just fills the nooks and crannies, if you will, in these sort of complex valley locations more precisely.
Another key component to the early warning system is the acoustic sensors.
The acoustic system provides sensing of the audio, the frequency content that threats have. Could be helicopters, gyrocopters, or Cessnas, and provides piece of the track that the system generates at the end.
A key feature that helps agents relocate the system is to run the sensor placement and optimization tool. This tool analyzes the geographical area and computes several factors, including line of sight, terrain analysis, site accessibility, and yearly solar exposure. After the calculations, the tool identifies the best placement, quantity, and types of sensors for optimal performance.
The technology that is involved is very advanced in the fact that it can not only hear the aircraft, it can also see the aircraft, give us tracks so we know GPS coordinates and exactly where that aircraft is going. It allows us to watch an area and be a force multiplier for an area that we typically cannot patrol.
Threats along the northern border can be challenging to track and intercept. S&T is assisting agents to have the latest technology to stay ahead of the adversary. Small Dark Aircraft Project is mobile, portable, self-sufficient, and provides agents the tools they need to keep our nation safe.